Welcome everyone. For today's prep, we're going to start to look at how to find the intervals of increase decrease for a function graphically. So that is, we're going to start to look at how do we locate the intervals where our function is increasing and the intervals where our function is decreasing just by looking at the graph of the function. And then kind of related to this, we're going to see how to figure out where our function has local maximums and where it has local minimums, again, given the graph of the function. So for this lesson, we're going to start to just look at the definitions and kind of how to do these things graphically. And where we're going with this is in the next lesson, we're going to see how we can do all of this using derivatives. But for right now, we just want to get a handle on the definitions and kind of visually, what does this look like? So let's start with our definitions for increase and decrease. So here we go. We say that our function is increasing on an interval, and what happens is the graph continuously rises. So it moves up as x goes from left to right through the interval. So what happens is as our x values get bigger in an interval, the function values also get bigger. So if x1 is less than x2, so if x2 is bigger than x1, well then an increasing function, the function value at x2 is going to be bigger than the function value at x1. So as x gets bigger, the function values get bigger. Our function's going up. Now, for a function that's decreasing on an interval, well, kind of the opposite happens. So the graph continuously falls. So it moves down. And another way to think of this is that as x goes from left to right through our interval, so as our x values get bigger, the function values get smaller. So for the case of increasing, the function values are getting larger. And for a decreasing function, the function values, as we read from left to right, are getting smaller. So as our x values increase, our function values get smaller. So if x1 is less than x2, or if another way to say that, if x2 is bigger than x1, well then the function value at x1 is going to be bigger than the function value at x2. All right, so let's look at an example. We're going to look at three graphs here, and we're going to figure out if our function is increasing, decreasing, or neither at the specified point at x equals c. And so another way to think about intervals of increase, decrease is essentially we're trying to figure out all of the x values where our point is going to be either increasing or decreasing. So let's kind of see how to do this on a point basis, and then extending it to an interval is kind of the same idea. So let's look at this first graph. We want to figure out if this function is increasing or decreasing at x equals c. So a way to tell is we find the corresponding point on our graph, and then we draw our tangent line at that point. So our tangent line will look something like that. And what we see here is that our tangent line is pointing up. So our function at this point is moving upward. So we say that it's increasing. Okay, well, so another way to see this is our tangent line has positive slope here. So a tangent line that's going up in this direction has a positive slope. What about the next graph? So here we have x equals c. We find the corresponding point on our graph. Let's draw the tangent line. And our tangent line here is flat. It's horizontal. So this has zero slope. When it's horizontal like this, it has zero slope. So our graph is it momentarily flattens out at this point. So it's not increasing and it's not decreasing. So we're going to say neither. It's kind of flat. All right, what about the last one? Well, again, we're interested in this point at x equals c. So we find the corresponding point on our graph. Let's draw in our tangent line. That looks pretty good there. And our tangent line in this case is kind of pointing down. So this has negative slope. And so that means our function is decreasing at this point x equals c. So essentially, when we're trying to find the intervals of increase-decrease, we're just trying to find all the x values where our function is increasing and all the x values where our function is decreasing. So we're just trying to get the interval, the collection of all the x values where our function's increasing or decreasing. All right, so this middle graph, something interesting's happening here. So when our graph flattens out, and there's other cases as well, but this graph in particular has something interesting going on at x equals c. And that takes us to our next set of definitions here. So we're going to define what it means for a function to have a relative maximum and a relative minimum, at specific points. So we use the term relative max, relative min. We also use local max, local min. So we just use these interchangeably. So first, let's look at the definition, and then we'll see, two basic examples. So first of all, a local max value of our function f is a number f of c such that f of c is greater than all of the surrounding function values. So it's greater than or equal to f of x for all x near c. So f of c is bigger than all of the surrounding function values. So that gives us a local max. A local min, it's basically the opposite. So a local min value is the number f of c such that f of c is smaller than all of the surrounding function values. So it's less than or equal to f of x for x near c. All right, so let's see some examples, some basic examples here. So let's look at the first graph right here. So this is an example. We're at x equals c, our function has what's called the local max here. So this is an example of what a local max would look like. And a way to kind of picture what's going on, if we think about our inequality is f of c, the function value at that point, has to be greater than or equal to all of the surrounding function values. Just right around x equals c. So eventually, maybe when we get further away, there might be other parts of our graph that eventually get higher. But right around this point, that should be the highest point on our graph. And that's what we're seeing. So imagine if we think something's a local max, imagine standing at that point. So let's imagine standing at that point, and right in the immediate vicinity, it's downhill in both directions. That's a sign you have a local max. Now, a local min is, well, it's kind of the opposite. So a local min is something like our second graph here. Or we'd also call this a relative min. And so we would say we have a local min at x equals c. We find the point on the graph. And again, for a local min, the function value should be smaller than all of the surrounding function values. So if you imagine kind of, again, standing at that point on the graph, it's going to be uphill in both directions. So just a little bit of terminology here. So generally when we're locating local maxes and mins, we would say something like we have a local max at x equals c with local max value f of c. So you want to think of the x value as kind of where the high point's happening or where the low point's happening. And then f of c is the actual value. So just a little bit of terminology there. So we want to think of the x coordinate as kind of like where this thing's happening. And then the value of our function is the max value or the min value. All right, so let's look at an example. Let's look at example 2. So example 2, we're gonna do the whole thing here. So we're given the graph of a function y equals f of x, and we're gonna figure out the intervals where this function's increasing, where this function's decreasing, and then we're also gonna locate the x values where it has a local max and where it has a local min. So let's look at our graph. And let's actually start with locating the maxes and mins. So when we do this, and maybe pause for a second, try this out for yourself, and then we'll go through it. So you should find that there are 2 maxes and 2 mins for this function. So we just want to find the x value. All right, so let's start with our maxes. So these are the high points on our graph. You want to think of these as kind of like the mountain peaks. So, well, there's one here. So we have a local max at that point. And then we also have a local max right here. So these are both local maxes. And again, you can kind of tell, imagine if you're standing at that point, if it's a local max and you took a step in either direction, it should be downhill, which in this case it is. Now it doesn't matter that eventually if we go far enough, then, we're higher up. We're just looking in this immediate area. Same thing over here. We're just looking in the immediate surrounding area for a local max. So at this point, we're standing there and it's downhill in both directions. Now for local mins, we got 2 of them, and probably the more obvious one is right here. So there's a local min, but we also have a local min right here. So for local mins, imagine standing at that point, and then it's uphill in every direction. Same thing, uphill in either direction if you move away from that point. So you have a local min. All right, so let's write it out. Let's actually answer the question here. We want to find the x values where we have a local max and the x values where we have a local min. So we have local max, and we'll answer it up here. So we have a local max, or you could use relative max, same thing. We have a local max at x equals, and now we just want to figure out the x value here. That's all it's asking for, the x values. So this point happens at x equals 0, and the other point happens at x equals -2. So those are our 2 maxes. And then we have a local min at, and now let's figure out where our local mins, our 2 local mins happened. So we have this point on our graph, and if we figure out, well, the x coordinate there is 3. And then for our other local min, the x value there was -1. So our local mins happened at x equals -1 and x equals 3. All right. So now let's figure out the intervals of increase, decrease. And locating these local maxes and mins actually kind of split up our graph into kind of sections. So we want to look for the sections of our graph that are moving up. So let's start with the intervals of increase. So let's figure out. So we look at this section right here, and our graph's moving up. So if I were to draw a tangent line at any of these points here, it would have positive slope. So this section is going to be increasing. And let me make that a little smaller. All right, so this section is going to be increasing. Now, if we go to the next section right in here, well, now this is moving downward. So our graph is getting lower. So it's going to be decreasing. So we have, so far we found in this section we're going to be increasing. In this section we're going to be decreasing. And then we just keep going like this. So if the next section of our curve, it's going to be increasing. And then the next section, well, what's going on? It's going to be lowering. So we're going to be decreasing here. And then finally, we get to that last point, and then we start going back up. So we're going to be increasing. So now let's put it all together. So to find the actual intervals, what we're going to do is we're going to think of the x-axis. So let's start by just kind of redrawing our x-axis. Let's draw it down below here. All right, so we got our nice x-axis. And then it keeps going out to plus infinity in one direction and then minus infinity in the other direction. And what we're going to do first is all of these places that we identify, these special points on our graph, we're going to indicate them on our x-axis here. So let's plot x equals -2. Something special happened there. Plot x equals -1. Something special happened there. X equals 0. Again, something special. And then x equals 3. Something special happened there. And what these points, what these x values do is they are essentially splitting up our x-axis, slicing it up into intervals. So this first interval, what did we find? Well, that first interval, if we write it out in interval notation, is going from minus infinity to -2. And what we found is that our function was increasing there. So our function f was increasing. Now this next interval, going from -2 to -1, so let's write that out in interval notation, going from -2 to -1. So we're basically just looking at this chunk of the x-axis here. That's what this represents. And we found that our function was decreasing. Then, in between -1 and 0, again, let's write that as an interval, so -1 to 0. We found that our function was moving up, so it was increasing. And then our next interval was 0 to 3. And we found that our function was decreasing there. And then finally, from 3 onward, it was back to increasing. So we would write 3 to infinity. So putting this all together, we can then say f is increasing on the intervals -infinity to -2, -1 to 0, and 3 to infinity. And let me just, we're increasing there. And then we can say that f is decreasing on the interval from -2 to -1, and on the interval from 0 to 3. Okay, so that's a fun example. So what we're going to see in class is we're going to do a few more examples like this. And we're going to see that these points where we switch, where we have these maxes and mins, these are going to be special. So these are going to kind of lead us to our general strategy on how we find where our function has a max or a min, or where our function is increasing, decreasing. So we'll see you then. Bye-bye.